The piece we still haven't described here is that f box there, the Feistel function. Here's an expanded view of that function f. The function has as inputs, remember, an element of the key schedule and the right-hand side of our current mixed-up plaintext. That half of the plaintext is 32 bits, and an element of the key schedule is 48 bits. So we can take those 32 bits and 48 bits and XOR them, at least XORing the bottom 32 bits. And then what the Feistel function f does is it takes each of those bits and feeds it into one of these boxes, S1 through S8. So S1 through S8, S stands for substitution. It gets a 6-bit number and it produces a 4-bit number. So every 6-bit number is mapped to some 4-bit number. And then each of those 4-bit numbers is combined back into now a 32-bit number, fed into yet another permutation here. Again, hardwired into the Feistel function, and that's how we get 32 bits out, which is what we wanted to XOR with the left-hand side of our current accumulation starting from the plaintext. Now, the actual substitution in here, it's just a table, but when DES was presented to the world, the reason for that table and how it was constructed was never explained. And so there was some concern that the particular substitution in that table somehow affected the algorithm in a way that meant that NSA could decode messages encrypted with DES. From the historical record now, it seems that in fact that these substitution boxes were correcting for a weakness that DES might otherwise had, but because the process was closed and the reason for this was not published in the model, then this algorithm was not trusted at the time of its release.